Hi everyone, my name is Marilena Pagano and I am the Application Specialist at Hellma. Today I would like to welcome you to our webinar with Dr. Carol Brigley on the topic Hit the Ground Running Toward a Smart Factory, Process Control Upscaling with Spectroscopy in the Food Industry. At the beginning, I would like to say a few words about the PAT-Forum. In 2017, Hellma launched the PAT-Forum as an annual live event in Mülheim in Germany to provide a networking opportunity for those interested in solving challenges with PAT and experts who are already running projects with success. Today, we have two types of PAT-Forums. One annual live event and several online webinars throughout the year. The live event offers a great lecture program with various keynote speeches and practical examples from experienced PAT specialists. It is a great opportunity for individual discussion and personal networking. While the webinars, with a 30-minute keynote on a specific topic, offers free and flexible participation from around the world. Today's expert, Dr. Carol Brigley, currently leads the Global Manufacturing Analytical program at Mondelēz International, where she works closely with the plants to implement inline sensors to monitor and control their cookie and chocolate manufacturing processes. I'm glad she found the time to share her experience with us. Welcome, Dr. Brigley.
Thank you, Marilena. So today I'm going to talk a little bit about our journey to a digital Oreo and how we started our smart factory project quite a few years ago, maybe 5-6 years ago, and how we've made this journey as of now. But I'd like to thank Hellma for inviting me to speak today. I really look forward to presenting the information and then getting some question and answers at the end. So the agenda is, who is Mondelēz International? I'm sure many of you have never heard of our name, but you probably know our products. So I'll go through a little bit of that. And then I'll talk about Industry 4.0 and the factory of the future. And then I'll talk about current status and trending themes in the food industry, our key drivers for moving to inline, typical benefits of APC, advanced process control, and then challenges in implementing these in our company in the food industry and in other industries as well. And then I'll talk about our journey to Industry 4.0, our Smart Factory initiative at Mondelēz, challenges we've faced, and then I'll give a summary. So who is Mondelēz International? We're, as a taste of who we are, this is from 2022. We need to update it into this year, but we're a multi-international company. We have plants around the world in over 150 countries. We sell our products around the globe. We have 79,000 diverse and talented employees. We have tech centers around the world where we develop our new inline technologies, and our product development is placed there, as well as factories across the globe. We exchange on the Dow Stock Exchange, the NASDAQ, and we have net revenues of approximately $28.7 billion. So really, the idea is that we want to have the right snack at the right time, made the right way. We're a snacking company. We're the #1 snacking company in the world, and we're #2 in chocolate. We're growing day by day, and our net revenues by geography, most of our sales are in Europe, and then North America, and then EMEA, and then Latin America. If you look at our $28.8 million net revenue, the majority of that is in biscuits and chocolate, 47% in biscuit, 32% in chocolate, 10% in gum and candy, cheese and groceries 7%, and beverages and 4%. We have a portfolio of consumers' favorite brands. You can see here, these are our billion-dollar companies, and this is our local gems, we call them. So these are products that have grown in individual regions around the world, and we wouldn't dare get rid of them because we know that our consumers really love them, like Club Social and Tate's, Lacta. There's quite a few different brands here, but our biggest sellers are Oreo, Belvita, Trident, Milka, Dairy Milk, Tang, Halls, Toblerone, and Philadelphia cream cheese. So like I said, you may not know our name, Mondelēz, but most likely you have eaten some of our products. We have 4 strategies, growth strategies. There's 3 listed here. The latest one is sustainability. As everyone else, we're obviously trying to do our part to improve the environment. So for our growth, we continue to deliver strong growth by investing in our brands. We are always buying new brands and divesting other brands off just to ensure that our portfolio is rounded and exactly what our consumers are looking for. And then we drive operational excellence through the world-class supply chain, through sales execution, and continuous focus on effective cost management and quality improvement. And that's where the PAT really comes in, the quality improvement. And our culture, we have a dedicated, diverse team, and we're always looking for new people to join our team. So if you know anyone who's looking, let us know. And then sustainability, like I said, it's not listed here, but of course that is one of our goals as well. By 2050, we want to be at net zero. And then also to get there, we're going to be reducing the amount of packaging we use, making more of our packaging recyclable, and then reducing the amount of the virgin packaging that we use. So what is Industry 4.0 and the factory of the future? So if we look at the 9 different areas of Industry 4.0, you can see quite a few of them have to do with process analytical technology. Obviously, big data and analytics, industrial Internet of Things is our way of communicating. Virtual and augmented reality, we use that quite a bit, especially if we're trying to work with a plant, but we can't get on site for whatever reason, we can actually work with them virtually. And obviously the cloud is where we store a lot of our data. And then modeling and simulation, of course, we're always trying to model some of our processes, our technologies. So that is a big area for us as well. So if we look at Industry 4.0 in the food industry, digital transformation is the key to get to the next stage of our processing, to really improve what we're doing, to improve our quality, reduce the waste, reduce variability. There's quite a few different benefits from going digital. And the way to do that is using sensors. So we've started to actually use sensors quite a bit in our lines, and that'll really help us in the future. And artificial intelligence-based autonomous systems is really critical to that as well. Modeling, simulation, I've already talked about a little bit, and that's all connected by the Internet of Things. So really, Industry 4.0 combines real-time process and product data to improve efficiencies from end to end. If you look at it on a cost, how much did this, was it estimated to the industry? It was $29 billion in the food industry in 2021. So we've really been able to benefit from Industry 4.0 by improving traceability, monitoring control of our food quality, improving safety, manufacturing automation, and training, predicting sensory and consumer preferences, and reducing loss and waste. And a lot of that has come with the use of inline sensors. And artificial intelligence has really blossomed over the past few years, and it's really allowed the food industry to combine human intelligence and machine learning to rapidly make decisions regarding product quality. And that's what we really need. We don't want operators to make adjustments to our lines anymore, because that just takes, it's not very objective, it's very subjective. We found in the past that when one operator would come in, they'd adjust the process to the way they liked it to run. When the next person came in at the end of the shift, they changed it to the way they liked it to run. And all of a sudden, the process does not look anything like it did just 8 hours earlier. So, and the product coming out is not the same. So we really want to get to the point where we're using sensors and automatic control, and we reduce the amount of interaction with the operator. But we found that this is really has been slow right now, because there are a lot of plants that we have, especially in our, in our network. We have a lot of plants that are older, and I'm sure other companies do as well. And the equipment cannot be connected to the sensors, or they cannot be controlled by the sensors. So we have to figure out a way to get around that. And we don't have PAT experts in all of our plants, so that is an issue for us. And then equipment between vendors may not be compatible. But due to the industry demand and the need for flexibility in production, we expect rapid advances in sensor technologies over the next couple of years. So what is the current status and trending themes in the food industry? So the current status is food companies are using both nearline and inline instruments to monitor manufacturing controls, more nearline than inline, but I think the trend is going towards inline sensors more. COVID has really reduced the access to the food industry production lines. There's really been a resistance to letting people into the plant, especially instrument vendors and people who are not actually working the lines, because we didn't want to infect anyone on the line, because it was critical to get the product out the door. Everyone needs to eat, so it's important to get our production, to keep our production lines going. Another trend is that the current status is increased availability of inline, nearline measured material product attributes has enhanced the capabilities and benefits of advanced process control. So really what we're saying is that the attributes that we're looking at, the ones, for Mondelēz, we say they're critical to quality, really has enabled us to use some of these inline sensors more. We found that some companies are using third-party integrators exclusively. They're ordering the instruments, they're setting them up, make sure they're running properly, and they're setting them for feedback control. It's something we've started to look into, but we still have a lot of control on what instruments we're using, what technologies we're recommending, and then how they go into the plants, how the operators are trained. That's still under our jurisdiction. What are some key drivers for moving to inline? Demand for implementing inline measurements remains strong, and manufacturing operations continue to adopt, renew, and improve their inline measurement capabilities. There's a strong emphasis on reducing operating expenses and improving quality as well. Consistency is important. We're finding that if we don't have consistent ingredients coming in, consistent processes, then we cannot control the quality as well. So the idea is with inline sensors and control, we can actually keep that variability down. We can keep the product quality high. And everyone is asking about inline analysis. I think the ultimate goal is total automation from testing those raw ingredients to the finished product. But then at a lower level, one thing remains consistent for some time, and that's the need for incremental capability upgrades to existing assets. And that is, our lines need to be updated to take on these advanced technologies and the control logarithms that go with it. The amount of data that has to be collected and stored and manipulated needs to be factored into as well. And a lot of our infrastructure is not there just yet in some of our plants, but we really need to work on that. And then the need for early stage proof of concept product and process prototypes has been consistent over time. So, we don't want to reinvent the wheel, but we need to make sure that we consistently think about what the consumers want and how do we get there. So what are some typical benefits of advanced process control, or PAT? It depends on where you are in the industry or what industry you're in. But obviously quality, we want to minimize variability in product quality and minimize rework or off-spec production. And that variability could be reduced 30 to 60%. We want to increase yield by reducing moisture variability and optimizing moisture content that maximizes yield. So we can get an increase in moisture of 0.1 to 0.5%. Energy, we want to reduce specific energy consumption. We can improve that by 1 to 5%. And then there's process optimization, optimize production, and avoid problems, adapt to prevailing raw material and ambient conditions. This is critical, as we found with COVID when there was shortage of some supplies. How do we quickly move to something else? How do we have an agile process where we can just switch vendors, switch suppliers quickly, maybe even switch types of products, the types of flour that we're using? How do we work towards that and improve our capacity at the same time? And then, as I said, agility, minimize impact of feed tank changes, and then faster time to come off product, higher overall equipment efficiency. So really, how do we improve the process and thereby improve quality? So what are some of the challenges we've seen? There's major issues with moving to inline sensors, and that's sample presentation. You can see in this picture here, this is an NIR system. This is our production line. And we found that, when we thought that the product was in the straight lines, it really isn't going under the sensor. So that's a challenge to the sample presentation, and we need to overcome that. The distance from the sensor to the product fluctuates, so therefore the path length is changed. We didn't realize that, we set up the NIR over the line and it was running perfectly for quite a few weeks, and then all of a sudden everything fell apart and we weren't seeing the results we were expecting. We found out that the mechanics had come out, they had changed the conveyor belt, they had moved it, it no longer was the same distance as it was previously, and that caused a problem for us. So now we're really sensitive to changes that happens when they do, cleaning and any kind of maintenance on the line. Scale up from pilot plant to full plant is not a simple exercise. Everyone thinks, oh, you're just going from a smaller version to a larger version, and that's not the case. The line speeds, the amount of data to acquire, just the way the product is processed in a pilot plant with only 4 product lanes versus 35 product lanes is very different. The amount of heat that's in it, how that heat is adjusted across the lines, that all comes into play. Plant digital maturity is a major roadblock. As I said, some of our plants are older, IT infrastructure is not adequate. How do we overcome that? It's cost a lot of money, obviously, to come in and overhaul everything. But obviously, when you change one thing, then you change something else. So you need to be cognizant to that as well. And we found that plants, labor shortages continue to present problems, not only from COVID, but after the fact. We're finding that in some of our plants, people are moving quite a bit to other roles, to other companies. How do we deal with that, especially when we're running such a high-level project as Smart Factory? Plants do not have control of their processes and try to correct one aspect and find that other issues need to be resolved. For example, we put online moisture sensors only to find out, and actually it was a good thing, it really told us how our heat flux in the oven was very different across the bands. So the center had a much different level of heat than the sides. We wouldn't have known that if we hadn't moved to inline sensors. So like I said, we tried to fix one thing and we found another problem, and that continues to happen over and over again. Many process-based projects are initiated by an engineer. They don't necessarily know some of the limitations of the technologies moving into online sensing. So that's something that you really need to think about. Successful applications occur when the vendor works with the quality manager who has a passion for quality combined with analytical knowledge, and an engineer who has a vision for process optimization. So it really needs to be a team effort. It's not just we go in there and say, this is what you need. They need to want it as well. Remote access tools are really important, but they also come with some cybersecurity issues, especially when we're looking at instruments that want to, attach to a server outside of our firewall. How do we deal with that? That needs to be, thought about early on in the projects. So a little bit about our journey, Mondelēz's journey to Industry 4.0. So we started our Smart Factory initiative about 5 or 6 years ago. It was an enterprise-wide, so it was something that, although we started with Oreo, the idea is to get to all of our lines, most of our lines in the future. We have what we call critical to quality parameters, and those are things like moisture, color, things that are really important to the consumer. Those need to be the focus of this project. So if we look at the Oreo manufacturing process, we have 5 units of operation. We have mixing, forming, baking, sandwiching, and packaging. And each one has its own unique set of challenges for implementing online sensors. So you can see here we have our unit operation, we have our sensor, we have, the data comes in, goes into a control mechanism, and then back out. And then what goes into the one unit operation is the output of the previous operation. So that's why these are arrows to the next. So what happens in mixing affects forming, forming affects baking, baking sandwiching, and then sandwiching, obviously, actually all the unit operations then affect packaging. So in our advanced process control scheme, here's a schematic drawing of our process. We have our mixer where our ingredients come in. We have a lay time conveyor where the dough sits for a certain amount of time to give it time to the proteins to really develop and some of the other things to happen, the water to dissolve, the sugars, all that has to happen over the lay time. We have sensors in here. Most of them are NIRs at this point. We have temperature sensors. We have also an NIR that's looking at the product going in and then coming out for the moisture. So then we have, it comes through a conveyor belt. The kibbler actually breaks it up into small pieces so that it goes into the rotary molder and covers up the dies. So as the product comes out, it's now formed into an Oreo and then goes through the oven and onto a cooling conveyor. And then it goes obviously downstream to be sandwiched and packaged. But we, you know, like I said, each of these unit operations, this is mixing, forming, baking. Each of these unit operations have its own set of challenges, and we have sensors to determine, you know, the critical parameters, not only critical to quality, but critical to process. So, you know, we need to measure the humidity inside the oven to ensure that the moisture is able to be released from the product. We have our stack height sensor, which is critical for downstream when it's trying to be sandwiched. If it's too big, it can't be sandwiched properly, and then obviously it won't fit into the package. So all these things need to take into account not only its own unit operation, but what's happening upstream and downstream. So what we have is a model predictive control overarching model that actually looks at, you know, what's happening in each of these unit operations. And if something happens in packaging, you know, one of the machines stops, it actually will stop some of this production or at least slow it down until that is fixed, or it will divert the product to a different packaging line. All this is controlled by this overarching model predictive control. So what was our business challenge? Obviously, we had multiple highly interactive critical product qualities that were going on. Obviously, moisture affects color, not necessarily in a dark Oreo like this, but if we were looking at golden Oreo, if we bake out too much moisture, the color is too dark. So those are things that are interactive, and we need to control each one of those together, and then, individually and then together. Operations and outputs of upstream have significant impact to the downstream process and final product qualities. We talked a little bit about that already. Major process variations are introduced by frequent raw material changes and daily equipment changes. Like I said before, if flour is added that's slightly different in its solvent retention capacity, that might mean that the operators would need to add more water. Well, if this was all done manually, it would take a while to figure that out, and then it would take some time for the change to be made. Then the process needs to be adjusted for that extra water that's added. So the heat may need to go up. All that cannot happen simultaneously when you're looking at manual control. But with a predictive model control, all those feedbacks and feed forward operations can take place simultaneously to keep the line at target. So our solution was to really have this model put in, and we can actually have it running consistently. We've added some soft sensors where we could, and we've had this model predictive control, this overarching control, really work the process. And what are our results? We really have seen quite a few improvements on the line. We've been seeing minimized disturbances from raw materials, equipment, and ambient environment to deliver consistent quality with overall product variation reduction by 20 to 50%. That is huge. If you think about, trying to improve the quality, what the consumer sees when they open a package, we want it to be consistent. So if one time they open the package and it looks like there's a missing cookie or two because the stack height wasn't right, that has all been minimized. So now when you open up a package of Oreo, they should look consistent within that plant, and then the goal is to every Oreo plant to be working to the same consistent quality. We've been able to improve inventory control, balancing upstream process output and downstream process demand. That has really improved overall efficiency of the plant. And then we've really generated a system of alarms to indicate when things are going wrong. So what are other APC initiatives at Mondelēz? That was biscuit. If we look at chocolate, same type of thing. We have our feedstocks coming into our line. We have refining happening, and this is the chocolate making stage. Then we have it sit for a little while, and then we temper the chocolate, and we mold it, we cool it, and then we package it. We have inline sensors at quite a few different stages. You can see here, we measure fat, particle size, viscosity. We have sensors to determine when the molds are dirty. There's a lot of things going on. What's the particle size in the raw ingredients, what the refiner flakes, and then the finished product as well. So we do have same thing. We have an overarching process control running the entire line, as well as individual process control for the unit operations. So that was another area where we saw huge improvements by putting process and analytical technologies on the line. But what are some of the challenges that we've been seeing? I talked to quite a few when I mentioned what's going on in the food industry as a whole, but I think Mondelēz itself definitely had some of those same issues. But one of the things we found that we really need to do was, look at the overall approval process of our inline technologies. So when we have our sensors, although they may have been piloted at one site, are they good enough to be moved to other sites? Do we know exactly, what is the food safety issues that might happen? Is there glass that could land in the product? Are there nuts and bolts that could land in the product? Those are all things that need to be thought about. Health, safety, environmental, we take a look at that as well. Obviously, analytical approval needs to happen. We need to make sure that the method's been written, that the technology has the rigor that it needs, accuracy and precision. And then what are some implementation rules, some watch-outs that need to be taken into account? And then plant engineering. What is the physical location? Is that good? Is it safe for operators to pull samples if need be? Obviously, mechanical and electrical need to look at it as well. Product process and pack. So the R&D folks need to look at the technologies to see if they follow all their rules. And then obviously digital. What is the output of these technologies? What is the output of the inline sensors? Do they, follow our regulations? Do they need to go through the firewall? Those are all things that we need to take into account while we're developing the technologies. And then obviously when we move it to a new site, we need to make sure that they follow all these same regulations. And then quality. We want them to be the last to sign off that everything is in place. We're looking at the right critical to quality parameters, and it's approved for use on any line throughout Mondelēz. But then, of course, that doesn't mean that any plant can just go off and pull a technology and put it into the line. We still need to be involved. The Analytical Sciences Group, or GMAP in our case, needs to be involved so that we make sure that they're setting up the instruments properly. Everyone's been trained. They maintain them if they need to be calibrated, especially the NIRs, other spectroscopy techniques. They need to be calibrated routinely. Is that taking place? So there's a lot to think about when we're looking at the challenges. So in summary, the food industry continues to move towards Industry 4.0, and we're really starting to see the benefits of inline sensors, artificial intelligence, process control schemes, adaptive process control schemes especially. Many instrument vendors, consultants, universities, and consortiums are being asked for inline sensors for feedback, feed forward, and predictive model control. And this is going to be key for Industry 4.0 and the Smart Factory Initiative. A lot of the advances recently have come from the use of artificial intelligence, which really allows for rapid evaluation of product quality without subjective human interaction. Mondelēz International, we've really started to use inline sensors quite a bit, along with process data to build predictive models, and we've found huge improvements to date to improve process variability, finished product quality, safety, efficiency, and waste. And I think forums like this, that Hellma is giving on a routine basis will really allow different industries to learn from one another and further enhance Industry 4.0 at an even faster pace. So thank you for listening, and I'll take any questions that anybody has.
I see the first question for you, Carol, is where is Mondelēz International located?
Oh, well, we're located around the world, but our headquarters is in Chicago, Illinois.
Another question is, how robust are the data models against production fluctuation?
Well, we found, when we do individual predictive model control on the unit operations, they're strong, but they're even better when we put them together so that it sees the input from the previous unit operation. Without that, it's not as strong, but they're really robust at the moment, yes.
Is the cleaning process necessary for the measurement interface?
Yes.
Yeah.
Yeah, so we have to make sure that the inline sensors can be done clean in place. In most cases, like for biscuit, if it's in the baking section, a lot of times they don't use chemicals or water. They just use air to clean them. Like we put an air purge window on our sensors sometimes to keep the dust out. But then in chocolate, obviously we need to be able to clean those sensors a little more vigorously. So we might use chemical systems. So we always look at the sensors, we talk to the vendors, make sure that you can use caustics, you can use other cleaning chemicals, you can use soap, but the goal is to get to the point where we have minimum amount of cleaning that's necessary. Maybe we can put in a sensor window that has a windshield wiper on it that actually cleans the window so it doesn't foul with protein from our processes. So yeah, we do keep that in mind whenever we look at inline sensors.
So we have another question. So can you comment a little bit more about the specific spectroscopy system you use, like NIR, IR, Raman?
Yeah, so we use a lot of NIR. NIR is probably the workhorse. We found that, we can do quite take different critical to quality parameters on an NIR. In some cases, we have filter systems because we don't need to measure more than moisture and say color in a biscuit product. But when we're looking at chocolate, we need to be able to measure particle size and fat and, quite a few other parameters. So we'll look at a full scanning instrument in those cases. But yeah, NIR is big for us. And then we also have obviously color instruments. We have temper meters in our chocolate line. We have a lot of vision systems going in now because that's, critical as well. And we want to make sure that the pieces aren't broken, they're not cracked. So we do use vision systems as well.
Also color measurements because the cookie color changes in time over the production isn't it?
During baking, it starts at one color and then it browns during baking. So yeah, that's critical.
Another question is if you already made an ROE or ROI calculation of your PAT projects, and if so, what are the results?
Return on investment, yeah, we have done that. In some cases, it doesn't look like it's going to be profitable, but once we have them in line for a year or two, they're definitely better. But we've also seen a lot of off-ramp projects come out of just having those sensors. Like I talked about the heat flux in the oven previously. That was something that came out, we put the sensors on, it didn't look like it was really worth it, but then we found out that we were able to improve some of these other things. So in that case, it's definitely worth it.
I have here another question. How long did it take to have the predictive model running as by now? And how big was the project team in the regards of resources?
So for the Oreo one, that was done in China, and we had, we hired obviously a company to do the predictive model control for us to develop those models. But when you develop the model, you have to do a lot of step test. So you have to go through and actually put the process through the paces. Like if you're going to be looking at moisture, you need to change the temperature of the oven up and down, see how that affects it. Obviously change the speed, change the thickness of the pieces coming out. So all those things have to come into play when you're developing the model. So I would say it probably took a good 3 years to develop. And as far as resources, we had maybe 3 or 4 analytical chemists involved, as well as engineers, process engineers, R&D people from the plant, and obviously instrument vendors were in and out of the plant, setting up their instruments and then, making adjustments and building models. So yeah, it was a huge endeavor, but we found it definitely was worth it.
So to inform you, you will receive an email with the contact details of Dr. Brigley and the YouTube video link. So you can contact Dr. Brigley directly if you have any questions about her presentation, for example. And if you have any suggestions for improvement on the webinar, I look forward to hearing from you. I would be happy if you would join us again and tell your colleagues about it. Thanks for your participation and have a nice day and goodbye. Thank you, Carol, for your time and for the presentation. I hope we see you soon.
I hope everybody got some good information out of it. Thank you.